Thank you for the warm welcome and the brief introduction. Feeling very, very proud today to represent Atlassian. Thank you for joining in this session. Today I'm going to give a tech talk about composing components for rapid delivery. In our journey at Atlassian, we have explored the transformational power of DRY and SRP, which is do not repeat yourself and single responsibility principle. By following the certain guidelines, we were able to compose the components in a much well-defined and the layered architecture. It helped us in increasing our dev velocity, remove the code duplication, and it brought a lot of consistency in our design. I'll walk you through the entire guided principles, the design pattern, architecture. I'll also take you to the real capability that we have developed at Atlassian. Let's start our journey. Our single admin platform at Atlassian is hosting 70 different applications. Our single admin platform in Atlassian is basically hosting 70 different applications. Admin platform is the platform which is used by admins of different organizations to manage operations. Let's say, as an admin, I have to move the data from one site to other. We have developed cloud-to-cloud migrations of Confluence and Jira for that. Let's say, as an admin, I want to take backup and restore of the humongous data from my source to the destination cloud. You can use backup and restore applications. As such, we have developed a lot of applications in our admin platform. Admin platform is the not only platform at Atlassian. We have UI platform of Jira, Confluence, Bitbucket, and Trello. With growth in our platform and our product offerings, we have seen exponential growth in our number of developers. Because of this growth, we have also seen a lot of code contributions in our platform level. With this exponential growth, we aim to move faster. We want to execute fast. We want to deliver more. But soon we started experiencing a lot of challenges. Our dev productivity and dev velocity slowed down. We wanted to execute fast. We had a lot of developers contributing, but code became harder to test. If I brought up any change in the code, its blast radius was very high. It was very hard to debug. Component behavior was very harder to understand. As a new developer, I started contributing to the same pool of code base, which was so extensive, they were not able to move faster. Components became harder to compose. I wanted to use the existing components to build other complex components, but I was not able to reuse it. Like any other company, we wanted to focus in solving this problem. So what we thought was, okay, let us build a contextless and stateless component, and we will achieve the reusability. It's a very common process among developers and the organizations that let's create a dumb component and I'll be able to share it organization-wide. We wanted to have the end results which is very layered and clean architecture. But that was a myth. I want to focus here that it's a developer's misconception that just by focusing and building a stateless and contextless component, you can bring out reusability in your process, in your design. We end up having a lot of components with a pool of unstructured code. But what went wrong in this design thinking? Okay, the culprit in the wrong part was we completely misunderstood the context. Our components became complex because of the humongous context that they shared with the parent. And why our context becoming complex? It is because of the data. The data which is needed by components to render in UI. The combination of state, context, data, which is tightly coupled with your consumer, has brought in a lot of complexities in our component design. You cannot create dumb components. Yes, you can create, but for the enterprise applications and scalable applications which Atlassian has, it might not be the good idea to just think about dumb components. But can you design a layer of components with data, with context, with state? Still your component remains shared and reusable? Of course, yes. We did the same. Here I want to focus on the two most important and guided principles, DRY and SRP. DRY is basically do not repeat yourself. If you have seen a logic in your component that can be shared, build it with a mindset that it is single, it is unambiguous, and it is not duplicated. SRP, single responsibility principle. If you are designing components in React, think about designing in the form of capability which can be shared. And don't design it in such a way that component will have multiple responsibilities. What is the problem if I design a component with multiple responsibility? Okay, let's say my product owner came and she said that, Ruchi, just there is a change in this requirement. Can you bring up this change real quick? Okay, I can't because I have designed the component which share multiple responsibility. So keep in mind that design your component with single responsibility in mind. Also, if you design a component with single responsibility in the mind, it can be shared across teams at various levels. Okay, so I'll give you a real example of a shared capability that we have developed at admin platform at Atlassian. So here is the problem statement. You have to develop a validation capability which will validate the artifacts in your process. On the right-hand side, you can see the snapshot of the component or a capability that you have to deliver. If you can see in the snapshot, you have different checks in the form of accordions. Space names and keys on destination is one check. Spaces with public access is another check. User installed apps is another check. You remember I talked about we have built an application which allows you to move the data from source to destination, which allows you to move the data of Jira. Consider Jira has one big organization. There are multiple Jira projects. One project has thousands of issues, thousands of logs, humongous history. Can you imagine the scalability that Atlassian is dealing with right now? So this validation capability we want to build before we allow users to move their data from source to destination, because we don't want their process to be failed. We want that we validate their data in source and destination, and then we allow to move them ahead. This capability is shared by across teams and admin UI. You can also see that each check or each accordion, which I spoke about, also has some action buttons. So basically, each of these checks also has the data associated with it. On click of buttons, you can actually call your services. Okay, so let's see how I have bifurcated this entire set of components. The first is design components. That is very usual. We all know they are atomic components. They are dumb, they are contextless, they are simple. All right. The second level of components highlighted in red box, they are capabilities. That's what I was talking about. They are stateful. They do the data fetching. They do the data management. But they are contextless with respect to its consumer. They are contextless with respect to its parent. They can have their own context, own state, but don't keep it tightly coupled with your parent. And very, very important that they are self-sufficient. I can still import the individual capability in my application, and I can reuse it across teams. The third bifurcation that is here is the page. So page is nothing but consider it as a combination of the capabilities, or which is importing just one capability, which is a combination of capabilities. It passes the relevant context to the capability. Because as I told that, these capability should not be aware of parent context directly. You pass whatever is needed to know as per the contract or as per the input. Told you about how we have bifurcated the entire component. So now let's talk about the architecture. You can see that there is we have basically instead of creating a hard-coded a big business logic of a component, just single component. We have dissected our components into multiple. Space conflict check, that is one accordion, one check can be one component. Group conflict check is another component. Product license check is another component. They have their own context. They also do the data fetching. Individual components can also do the data fetching, data management. They call the services. But the important part is they are not coupled with the parent. They always act based on the contract which is passed to them. Internally, in these stateful components, you can have layer of different components that depends on you, how you want to design it. What I want to emphasize here is the way we have dissected the component, which is not just dumb, it is playing with the data, which was the male culprit before when we were just designing the dumb components. In turn, all these components uses the admin hub or Atlas kit, which is our Atlassian's design system common components. They are basically the stateless components. And the final result is just import this validator capability, pass the contract. With just few lines of code, different teams can use this capability. That's how simplistic it is. Think about how I have achieved this and what was the issues you can get while achieving this. What if your capability or your component is talking to different services? Will it help you? I don't think so. You have to always think about unified approach to data management. On the right-hand side, you see, my component is talking to a router or a middleware, which routes the call to the different services. And there is also an adapter layer, or there is also a logic layer, which massages the responses and give me the unified response. And that's how I can create a capability with single responsibility, single unification approach. The second point I want to bring to your notice is standardized way to develop the components. When you're developing the components, always think about not tightly coupling it with your application. Always think about, is my component self-sufficient, that at any point of time in future, if other teams want to share it, can I give them this capability? And these components should be highly extensible. I want to close this topic on a very positive note, telling you about our journey. Yes, I told you, we are increasing product offerings. We are hiring. We have exponential growth in our developers' perspective in the code contribution. In turn, with more code contribution, basically we are building a lot of different capabilities. As we develop number of capabilities, our number of product offerings has increased that we are delivering it to the customer. In turn, that increase our developer delivery and the velocity. Now we are able to deliver fast. Why? Because every team doesn't have to create the same capability. There is no duplication of the code. When we are delivering fast, we have seen the tremendous customer growth. Our customer is growing, and Atlassian is growing. I want to leave you with the thought that can we just think about when designing the component, not just about the component at the atomic level? Can we also think of designing the components having data in mind, having context in mind, having complex state in mind? I think that would do wonders, wonders, and wonders in your design architecture. Don't think about building the capability. Let's say I will not reach to the end result by just building the capability on the very first day. Can I build and code my component in such a way that I can extend it for future use? Of course, yes. Thank you so much for joining in this session. Our Atlassian booth is outside. I will be there to help you to answer all your questions. Let's catch up there. Thank you.